Alright, we are going to look at 3 periodic trends. The first one is atomic radius, second one ionization energy, and third one electronegativity. So first one, atomic radius, this is the size of the atom. And the trend is that it's going to increase as you move to the left and increase as you move down. So increases as you move to the left, increases as you move down. And so the largest element, or the largest atom, would be francium, Fr. The reason why it increases as you move down, or why the atom gets larger, is because you have more energy levels. So if you look, if you think hydrogen has 1 energy level because it's in period 1, lithium has 2 energy levels, sodium has 3. And so if you drew it, hydrogen would have 1 energy level, lithium would have 2 energy levels, sodium would have 3 energy levels. And so you can see as you move down on the periodic table, the atoms get larger. The second trend is ionization energy, and this is the energy required to remove 1 electron from an atom of an element. The trend is that you increase as you move up, increase as you move to the right. So the element that has the greatest ionization energy would be helium. And so the reason why the noble gases have the greatest ionization energy is dealing with their valence electrons. And so all the noble gases, are like neon, argon, krypton, those all have 8 valence electrons. So they have a filled outer shell. And so that is what every element wants. And so those noble gases are completely happy. They have everything they want. And so in order to remove one of those, it takes a lot of energy. And so that is why the noble gases have the greatest ionization energy. The third trend is electronegativity, and this is the tendency of an atom to attract electrons to itself. The trend is just like ionization energy, that we increase moving up and we increase moving to the right. However, noble gases do not count because they already have all the electrons they need. So if we take the noble gases out and we look at farthest up, farthest to the right, our element would be fluorine. So fluorine has the most, or the greatest, electronegativity. And so the reason is, like I said, if you had a noble gas, if you had neon, neon has 8 valence electrons, because it is in column 8A, 8 valence electrons, and so it is not electronegative because it does not want to attract electrons to itself. It already has everything it needs. So it is not electronegative. If we look at fluorine, though, fluorine has 7. Fluorine is almost there. All it needs is one more to go right here. And so it really, really, really wants another electron. And so its tendency to attract electrons to itself is going to be really strong. And so that's why it is the most electronegative. Shielding is something that it deals with moving into different energy levels. And so if you have your proton and you've got one energy level in your electron, the attraction is not very shielded. If you move down the periodic table where you have more energy levels, so you have your protons, and then maybe you have 3 energy levels of electrons, the attraction between your protons and your electrons is shielded, and so it's called a shielding effect. And so as you move down on the periodic table, you increase shielding effect. The other thing to look at is something called effective nuclear charge. And if you think of nuclear sounding like nucleus, it's dealing with if you're moving sideways on the periodic table, if you're moving along a period. And so if you think of having one proton and one electron, okay, you've got an attraction there, but you have more charge, more nuclear charge. As you move to the right, if you have, say, 5 protons and 5 electrons. So as you move across a period, as you move horizontally, you will have, as you move to the right, you will have more nuclear charge. A general rule of thumb is going to be when we're comparing elements, and we'll be doing this in class so it'll make sense. But if you're moving up and down, the reason that you will be looking at or using is going to be shielding effect. Because shielding deals with more or less energy levels, and if you are moving side to side, the reason is going to be effective nuclear charge. Because that's dealing with more protons, more electrons. And so more would be on that side, less. This would be less shielding, and on the bottom would be more shielding.